Quadrilaterals. Exercise 8.2. Exercise 8.2, question 5. We have to prove that DP is equal to PQ is equal to QB. AF and EC trisect the diagonal BD. Now what? Let's mark all the congruent things. F and E are midpoints. Is there any triangle where we can use them in the midpoint theorem? We'll first have to prove that AF is parallel to EC, right? Now, AB is equal to DC, opposite sides of a parallelogram. AE is equal to FC, half of congruent line segments. AE is parallel to FC, opposite sides of parallelogram ABCD. Therefore, quadrilateral AFCE is a parallelogram. Is there any triangle where we can use lines from F and E in the midpoint theorem? In triangle CDQ, we can say that P is the midpoint of DQ. Therefore, DP is equal to PQ. In triangle APB, we can say that Q is the midpoint of PB. Therefore, QP is equal to BQ. That's it. Done. You got it. Now, do fair work. Question 5. In parallelogram ABCD, E and F are the midpoints of side AB and CD respectively. Show that the line segments AF and EC trisect the diagonal BD. Given, ABCD is a parallelogram. Therefore, AB is parallel to DC, opposite sides, and AE is parallel to FC. Let this be 1. Also, AB is equal to DC, opposite sides. Therefore, AE is equal to FC, half of equal sides. Let this be 2. From 1 and 2, AECF is a parallelogram. Therefore, AF is parallel to CE and AE is parallel to FC. We have to prove that BD is trisected, that is, DP is equal to PQ is equal to QB. Now, in triangle CDQ, F is the midpoint of DC, given. FP is parallel to CQ as AF is parallel to CE. By converse of midpoint theorem, P is the midpoint of DQ. Therefore, DP is equal to PQ. Let this be 3. Similarly, in triangle APB, E is the midpoint of AB. EQ is parallel to AP as AF is parallel to CE. By converse of midpoint theorem, Q is the midpoint of BP. Therefore, PQ is equal to QB. Let this be 4. From 3 and 4, DP is equal to PQ is equal to QB. That is, these are 3 equal parts of the diagonal BD. Thus, the line segments AF and EC trisect the diagonal BD. Exercise 8.2, question 6. Given, PQRS are midpoints of the sides. We have to prove that PR and SQ bisect each other, and PT is equal to TR and ST is equal to TQ. Now what? Let's mark all the congruent things. Since we have midpoints marked, we can draw diagonals and try to use the midpoint theorem. So, we can see that in triangle ABC, PQ is parallel to AC. In triangle ADC, SR is parallel to AC. Similarly, PS is parallel to DB is parallel to QR. So, quadrilateral PQRS is a parallelogram. Quadrilateral PQRS is a parallelogram. Let's mark congruent things in quadrilateral PQRS and see. We can mark opposite sides and alternate angles. And vertically opposite angles. Now let's see if we can find something connecting the sides we want to show as equal. Triangle PTS is congruent to triangle RTQ can be shown by ASA test. Then PT is equal to TR, CPCT. Triangle RTS is congruent to triangle PTQ can be shown by ASA test. Then ST is equal to QT, CPCT. We are done. The final part can be proved in a smarter way using a property of parallelogram. Note that diagonals of a parallelogram bisect each other. So, in PQRS, PR and QS bisect each other. That is, PT is equal to TR and ST is equal to TQ. We are done. You got it. Now, do fair work. Show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. Here, ABCD is a quadrilateral such that AB is not equal to BC is not equal to CD is not equal to DA. Also, PQRS are midpoints, so we have AP is equal to PB, BQ is equal to QC, CR is equal to RD, and DS is equal to SA. In triangle ABC, P is the midpoint of AB, Q is the midpoint of BC. Therefore, by midpoint theorem, PQ is parallel to AC and PQ is equal to half AC. Similarly, in triangle ADC, S is the midpoint of AD, R is the midpoint of DC. Therefore, by midpoint theorem, SR is parallel to AC and SR is equal to half AC. Therefore, PQ is parallel to AC is parallel to SR. Similarly, PS is parallel to BD is parallel to QR. Also, PQ is equal to SR. Similarly, PS is equal to QR. So, PQRS is a parallelogram. Since the diagonals of a parallelogram bisect each other, PR and SQ bisect each other. Therefore, PT is equal to TR and ST is equal to TQ. Hence, proved. Exercise 8.2, question 7. We are given angle C is equal to 90 degrees. DM is parallel to BC. We have to prove that D is the midpoint of AC, that is 1. AD is equal to DC, 2. MD is perpendicular to AC, and 3. CM is equal to MA is equal to half AB. Now what? By midpoint theorem we can show that AD is equal to DC. MD is parallel to BC, so angle ADM is equal to angle ACB, corresponding angles. Draw CM. Mark congruent angles and sides. AD is equal to DC. Angle ADM is equal to angle MDC. DM is equal to DM. Therefore, triangle ADM is congruent to triangle MDC, so MC is equal to AM. And we know AM is already half AB. You got it. Now, do fair work. Question 7. ABC is a triangle, right-angled at C. A line through the midpoint M of hypotenuse AB and parallel to BC intersects AC at D. Show that 1. D is the midpoint of AC, 2. MD is perpendicular to AC, 3. CM is equal to MA is equal to half AB. We are given angle C is equal to 90 degrees, MD is parallel to BC, MA is equal to MB is equal to half AB. In triangle ACB, M is the midpoint of AB, given. MD is parallel to BC, given. Therefore, by converse of midpoint theorem, D is the midpoint of AC. Let this be 1. Since MD is parallel to BC and AC is transversal, angle ADM is equal to angle ACB, corresponding angles. Therefore, angle ADM is equal to 90 degrees. So, MD is perpendicular to AC. Let this be 2. In triangle ADM and triangle MDC, MD is equal to MD, common, angle ADM is equal to angle MDC, both are right angles. AD is equal to CD, from 1. Therefore, triangle ADM is congruent to triangle MDC by SAS test. Therefore, MA is equal to CM, CPCT. But MA is equal to half AB given. Therefore, CM is equal to half AB proved. I got a telegram. Mine is a quadrilateral with parallel opposite sides. I got a parallelogram.
If you like our videos, do share them and subscribe to our channel. If you want awesome quizzes, write to us. Keep watching and keep learning with Walnut.